Hi, everyone. Welcome to the HamSCI biweekly Telecon. I guess we'll start with the updates. I've been extremely busy trying to get ready for Hamvention and for, just keep going with the different research and the grants. And I think it's coming along well. Sometimes it's trickier than others to keep up with everything, but I think we're making progress. So, Bill, would you like to give an update?
Sure. I've been working on the machine learning stuff where we take plots of spot data aggregated from PSK, Whisper, and RBN, plot those as like a HF radargram, like comparable to what SuperDarn uses, and then we use an object detector system to look for patterns that look like TIDs in there. So recently, the last couple of days, what I've been working on is revising the paper, but also getting the thing to where it would handle 40 meters. And also, I'm gonna have to study on this a little bit. It seems preparing the data is very slow, and it's to process for a single day's worth of data, aggregated RBN, Whisper, and PSK. It takes close to 10 minutes per day of data. And so if you say, well, can you rerun this to include a different threshold, or can you do, okay, well, I have it for you in about a week. So there may be a way to optimize that. I don't know. But anyway, that's what I've been doing.
Okay. I guess the thing to do is what we're doing first, which is basically coming up with the right algorithm. And then once we get an algorithm that we're like, okay, we know this works, then we can work on optimizing it. I was curious, how portable is your code? Like if we wanted to have someone else run it, how hard is that?
Well, the code that's doing all of this is written in Python as you requested.
Mm-hmm.
So whatever the portability of Python is, now to have the object detector run at speed, you have to configure you have to have a GPU in your computer and configure your system to use it, which can take, it can take a talented IT guy a couple of days to get that working sometimes. But anyway, given that you can get the GPU to work under Python, it should be comparable, should be runnable on other systems. So
yeah, that sounds great. Great, Bill. How about Dave, W6OQ?
I'm just here for the party. I'm just hanging out to see what's going on, and maybe someday when I have more time after the house remodel is done, maybe find something to contribute.
That sounds great. Thank you. Mary Lou, how are you doing?
Okay. I found something interesting about the Tonga earthquake and blast wave. Well, two things. One historical thing, that there was an eclipse of the sun during the Tonga at Tonga in the early 1900s, and it was clear where it was cloudy at some other place. Another thing is that they were testing a model of predicting earthquakes, and found that it doesn't work. So they ended up with, well, this prediction method is no better than just random guessing. And it had to do, I thought it was interesting what they were trying to do, and somebody thought this evidently did work previously in other cases, is that there's a background seismicity going on all the time, and they do a correlation with how much the background is compared to the tides, the interior Earth tides, which come twice a day. And if there's more seismicity in concert with the tides, then there may be a big earthquake. But no, it's just random guessing. So that's what I learned this week.
That's too bad. That's just random guessing.
Yeah.
Yeah. David Kasdan.
Oh, not too much to announce. I got today the automatic sound recording working for the weekend recording effort. So I should have a bunch of files to update, to upload for that, for Christina's project.
That's great.
Yeah, I'm not sure that many people have been doing it though. As I've asked around, I'm not sure this one's had a good response. So I'll ask you, are you set up for that recording?
I am not.
You need any coaching for it? It's not that hard.
I wish I have zero time. We have a band concert on Saturday night, and I've got rehearsals tonight and tomorrow night, and I'm running around trying to make sure I'm ready for Hamvention, and I'm trying to work on the other grant proposal and trying to do more data analysis. And
Right. Okay. Apropos the proposal, we'll be cutting off to meet with Rachel and her potential advisor at past. And I'm glad that you made connection with Hans Summer from QRP Labs. That one has a lot of promise for the things that we're doing.
Great.
I'm gonna make a connection with him as well, because I want to promise him, since I know where his booth is now, I'm going to be able to finally be sure to cross paths with him, because I want to give him one of the second tick units and this coherent CW
Good.
/ coherent. You understand.
that sounds great, David and John. And then Jim, K4BSC.
And sorry I was late. I'm having trouble with Zoom for some reason. Not a whole lot to report on the project. I spent some time trying to get up a couple of antennas this week, and I finally got a Franken antenna up yesterday. You wouldn't believe it. 4 ropes in a tree to get this one 10-meter vertical antenna up and kind of in position. But it seems to work.
That's good. Glad that's working. Is your grape still up and running?
Yes, it is.
Okay, that's great. I was talking with I was working with my student Veronica today, and she's trying to do the TID triangulation project.
Oh, yeah, yeah.
And, yeah, and it looks like we're looking at the map of where all the stations are, and it looks like yours might be in a particularly valuable location for what we're trying to do.
Oh,
So,
good. I'm glad to hear that.
yeah, so we are working on that. So
Well, it's still running fine.
great. And I can show you some pictures that Christina has been making up too. She's starting to go through all the data, and she's starting to see some very interesting things. So I can show that in a few minutes. That sounds great,
Good.
Jim.
Good.
Carl, how are you doing?
Oh, I'm doing fine, Nathaniel. Hello to everyone. Just listening in. That's about it.
That's great. Are you going to Dayton, Carl?
Oh, I'll be there. Yes.
Great. Would you be interested in giving a booth talk for HamSCI?
Yeah, it depends on the time, of course, but yeah, I could do
The
something.
time is flexible.
Okay.
So we have a certain number of time slots. I
Okay.
have already invited John over here to give one as well.
Okay.
So
What about 20 minutes or something like that?
yeah, so I'm thinking 20 minutes and then Q&A after.
Okay.
And
I
it's
can do something.
because it's a booth talk. This is going to be in the Ham Radio 2.0 area, right
Yep.
next to Neil Rapp's booth, and it's going to be, just so you know, it's going to be a bit of a noisy environment. So there's supposed to be a sound system, but just be prepared that it may not be as smooth of a presentation space as you may be used to.
Well, I think I've done it before there at the booth there, and it was quite, kind of noisy, but that's okay. Not a problem.
Okay, great.
I printed the map where all the HamSCI stuff's going to be, so
Wonderful.
find my
that-
way over there.
That will be great. I'll bring that information up in a minute here, and then we can maybe pencil you and pencil John in
Yeah.
for a time.
So you want me to do something on the mating habits of the South African honeybee, right?
Yeah, that's right.
Yeah.
Okay, good. All right.
Yes. And
Finally.
how they're affected by HF electromagnetic
go.
energy.
All right.
Well, they have antennas, right?
Yeah. Have to run my bees through the antenna pattern, huh?
Yeah.
What happens? Yeah, okay.
Yeah. And so then we have let's see, how's Bill gave you gave us an update already, didn't you? My Zoom thing is moving around here a bit. Mike Neruda, and he says greetings. Camera and microphone not plugged in. Greetings, Mike. Nice to see you. And let's see, then David McGaw.
Afternoon, everyone. I'm here at the lab doing some mad last minute tweaks, presumably to our Baffin Island system. We're supposed to take that up into Canada this next weekend, next week. This weekend we have Nearfest, probably the biggest ham flea market and such in the Northeast. And what was the other thing? Oh, as I mentioned this morning, there was some interesting propagation yesterday. We had a couple of G1 geomagnetic storms, and apparently there were a bunch of flares. And 10 o'clock last night, I was scanning through WWV, was getting Hawaii on 15, was getting very clear up through 20, hearing warbling on 25 megahertz. This is 10 o'clock at night. And so I went on the bands and tuned around on 15 meters and found someone in Colorado to brag chew with, whose signal was getting better, not worse, during the QSO. So gotta love propagation. Back to net.
Thank you. Are you going to Dayton?
I am not.
You're not. Okay. So I won't be able to ask you.
Sorry.
Darn. You're off the hook on this one.
If you did Zoom, I'd be willing to do it, but
that would be good. I don't know how well the Zoom is going to work.
Yeah.
It
would be tough in a booth environment.
Yeah, I think it's better to have real people in
Right.
for this one. I might.
I don't know how real we are, but whatever.
I might see if some of my students want to do. Some of them are giving a forum, but some of them may want to do a booth talk as practice or something like that. So maybe
That's not a bad idea. Throw them in the pool.
Yeah, so that might be a good way to do it. So, and then let's see, Mitch Easton, how about you?
There we go. Afternoon, all. I'm QRUNV. I'm waiting for the birth of the Grape 2 very patiently. Cannot wait. Carl, you might want to consider the life and times of the South African barking spider.
Oh, okay.
As a possibility for a talk.
Hey, I could maybe both of them go together. Yeah.
I'm QRT for a while. I lost a vertical in a recent windstorm. I had a couple. I got a 05 10 through 40 vertical. Had a couple radials chopped off by limbs. So waiting for parts to rebuild that. Otherwise, just in sponge mode.
Great. Well, very nice to have you. And then let's see, it looks like Todd Christel is joining us. Hello, Todd, how are you?
Oh, let's see. Oh, I guess I'm unmuted. I'm doing good. How are you?
Good. Do you want to give us an update?
Let's see. Well, let's see. I mentioned on Monday that I went to a HamFest a couple of weekends ago and bought 3 Bodner GPS DOs for brand new for $150.
That's great.
Yeah, two minis and 1 dual port. That actually wasn't the deal I got. A guy had a stepped attenuator there, which I'd been looking for. So it's like, how much for that? He goes, oh, $5. And I'm like, oh, okay. Yeah, I know. Well, and I'm thinking, you see them on eBay for like $100, 120. It's a Narda microwave. I mean, you can buy them from Mauser for $7,000.
Yep.
Yeah.
So it's like, so, it's kind of like my fly rod. It's like, I will never be good enough to deserve that. So anyway, so now I got all the parts and I'm building another grape station so that I can run the DRF on at 5 megahertz and I can run the normal software on 10 megahertz. And so at some point I'm going to need another node number, but
Actually, you won't. You just have the different, you'd be the same node. Nodes are based on geographic location.
oh, perfect. Okay, well then, as soon as I get the last solder joint, I'll be able to go then.
Yeah, it's just the way the file naming convention handles all that.
Okay, good to know. Anyway, so yeah, that's my update.
Great, thank you. And I'm getting a text from Christina in here. I just need to make sure that there's something not in here before I show it on the screen.
I do have an update as well.
Go for it. Oh, I missed you.
Yep.
Sorry. Well, go ahead, John.
What I'm sharing now is what's supposed to be coming at me tomorrow. This is Gen 2 of the data sequencing engine for the Grape 2.
Wow.
Yeah, that was about 70 hours worth of work. It's a 4-layer board, lots of parts on both sides. So that's just the digital logic component of it. There's no analog RF or any of the analog front end stuff on this. So once I get this working, then I start on the RF deck.
So how many boards are there going to be for the Grape 2?
I'm thinking I'm going to separate the RF deck from the digital deck, so it'll be 2.
Mm-hmm.
I'm debating if I want to size the boards so we can put them into a case, like one of those extruded cases. So I'm playing around with that idea. But the problem then becomes, how do you cool the Raspberry Pi 4? So, you know, it got those issues to deal with. So. But anyway, that's what I'm up to. This is coming tomorrow. Hopefully be building it, if not this weekend, early next week, and testing it out and getting it to Bob Benedict to start testing with. But this is the Neo, and then the temp sensor for the Neo. This is the complete mag temp interface there. This is the entire power supply up in this corner. This is the RF, or I'm sorry, the analog marker system for the top of second that marks the full scale ground and then signal for the analog channels. And then all this stuff in the middle is all the digital control logic to run the sequence engine. And then down in U1 here in the lower right corner is the 3-channel SI 90, whatever the 3-channel frequency synthesizer is that I'm going to generate clock 0, 1, and 2, which will be running radios 0, 1, and 2. So we have the basics for Bob to be able to program that and generate the right frequencies for the radio mixers.
You're gonna have to assemble the prototype manually, or
Nope,
you have?
nope, there is no way.
Good. I didn't think so.
This IC right here that I'm circling, can you see my cursor?
Yep.
That one right there is a 10,000th pin on 20,000 centers.
Ouch.
I can do it by hand. Not too many other people can, just because I've done enough of them that I'm used to screwing them up and then fixing them.
Yeah.
But that and IC 515, which is the temp sensor, is also on pretty tight. These are on 25,000 center pins, because these pads here are on 50,000 centers. So you get an idea how tight these things are. So there's no way, because you can't get these parts in any other package. Otherwise I would have put them in a bigger package, because obviously I have the room to do it, but you can't get them in the packages. So, and there's going to be over 200 parts on this board. And the other board, you add that, probably, it's just, no, that would be, people would kill me.
Yeah.
And rightfully so. So back to Ned.
Well, that looks like very, very, very good progress. So,
John, quick question.
yeah.
How many of those parts are stuck in the supply chain?
The U-Blocks GPS receiver, you can get some now, but for a while they were unobtainium. The frequency synthesizer is unobtainium right now. The voltage regulator is unobtainium. The D flip-flops you can get. The analog switch right now you can get, but that may turn into unobtainium. So I'm trying to work with what I've got. That's why I didn't go with an FPGA, because a CPLD would be perfect for this. I could eliminate, most of the logic stuff on there, and have it done in 2 days, but you just can't get them and rely on getting them. So, and then programming them and all that kind of stuff is another issue you have to take care of in this for production type stuff. Whereas my board, you don't need to do any of that. So there's trade-offs on all that stuff. So
Yep.
to answer your question, yes, we have issues, and we're going to have to cross that path when we get to it.
Roger that.
They keep promising they're going to show up, but they keep pushing dates out. So you're shooting at a moving target.
Thank you.
John, I might mention, you talked about cooling the Raspberry Pi 4. CanaKit does have a metal case that
Right.
cools it by conduction. I don't know if that helps any. There is a way to get a interface cable out of it.
Actually, I have one of those, and the problem is that since I'm plugging the Raspberry Pi into my board, that case will not work.
Right. You can't use an extension cable.
Exactly. It doesn't fit. So
Uh-huh.
it's something else I have to, the thermals of that one is going to be a challenge. So we'll hopefully figure it out.
High pressure air, I guess.
Yeah. Just moving the heat to the outer shell would be enough, but that transition piece is going to be tricky.
Somebody's going to have to make a liquid cooling system for Raspberry Pi.
They do make one. You can get one. They just came out with them, but they're expensive. And you're running
your
with
point
water
is-
and water and or the antifreeze and piping and
Right.
all the cooling fins and blah, blah, blah. It's a mess.
Well, I'm surprised they don't have a passive cooler like they do in
Oh, like for the Pentiums.
in
with
laptops.
power. Yeah.
Yeah, it just has a heat pipe.
I don't think there's enough demand for it because that production, usually they use some very exotic materials that does the thermal conduction loop.
Yeah.
And that is problematic if you don't do it right. And yeah, there's a lot of issues, but it really comes down to volume.
Right.
If you just made 200 of these things, the NRE would make it cost prohibitive.
There must be a laptop out there that you could steal it out of.
And buy about 200 of them.
Well, that sounds really good. So I wanted to show you a plot that Christina made because I think it's a really, really nice plot. And I know people have been collecting data with grapes for a while, and sometimes they get questions with, what are you doing with all of the grape data? And Christina is now going through and she's trying to aggregate all the grape data, which I know people have been contributing to this server, and she's been starting to do some analysis on this. And I think this is a really nice figure that she just came up with. And she showed a version of it at this morning's meeting. But this is showing 2 years of data from John Gibbons's grape station. And I think this is really a very convincing figure showing how well it really does track, seasonal and diurnal variations in the ionosphere. And so what you're seeing is Doppler shift. Here, the red Doppler shift is positive and the blue Doppler shift is negative. And for various reasons right now, midnight is in the center of the plot. So you have time of day going along this axis, and midnight is in the center, and then dawn is at the edges. Or I should say, not dawn, noon is at the edges. So noon is at the edges, midnight is at the center. And that would make over here, this blue, which is negative Doppler shift, this is going to be the dusk transition. So you gradually lose the ionosphere as you go into night, and you're seeing negative Doppler shifts as the ionosphere moves up. And then you have the nighttime, and then morning comes and you see a hard transition into the morning as the sun comes up, and that's all a positive Doppler shift. You can see that in the winter time, you have more hours of night, and then in the summertime, you have less hours of night. And we're also seeing that in the summer, we actually have more negative Doppler shifts, which we think might be more TIDs going through at night, but we don't really understand that seasonal variation, why we have more white over here and more blue over there. We also don't understand why the blue is somewhat gradual over here, but it's very intense over here. But we're seeing some really interesting things. So Christina's starting to make these plots for all of the different stations and trying to figure out more of what's going on in here.
One thing I would mention is that from, see, when did I change antennas? The mag loop is like for all of 2022 and probably the last part of 2021. That might explain the blue stuff in the middle of the right-hand side. Because my
Why
noise,
this is
yeah,
so intense.
yeah. Because I'm
So
getting
there's a
better reception,
possible.
getting better reception with the mag loop.
Okay.
So that is all in the metadata. So she can actually figure out when I changed antennas, because I kept up on that. So in the metadata, it'll say what the antenna is that was being used.
Okay. That's really
So,
good to know.
yeah.
Yeah.
And like I say, the right-hand stripe on the very right side is where my wall wart fell out of the wall that was powering the mag loop for 7 days. It was on the floor.
Oh, wow.
Yeah. It's like,
Okay.
oh no, the thing is going to shoot me.
When
So,
I was in graduate school, I heard a story, for various reasons, there's a lot of space physics instrumentation is co-located with farms of various types, because a lot of people who want to put up receivers in various places look for places that are fairly RF quiet and don't have a lot of things going on. And it turns out that I guess farms are a good place for this sort of thing. And you can ask a farmer, can I stick this antenna out there? And most of their livestock or whatever don't bother it too much. But sometimes the livestock does bother it. And so I've heard about papers where they will have data point, data point, data point, and then there will be a letter C. And if you look in the notes, C stands for cow, which interfered with the measurements. So yeah, so it's something like that.
yeah, I've actually got 84 acres of farmland about 60 miles east of me, and there is
Wow.
nothing around it. And I'm trying to set up, so I've got solar power out there, but I'm not quite sure I have an internet connection to be able to put it up. But that's where my first grape 2 is going.
That's
There's
great.
nothing around there, absolutely nothing.
That's really great.
Unless the fish in the creek make noise, but I don't think that's going to be caught by the antennas.
Yeah, that's really good.
So I was wondering, would the cow magnet do anything to some of this equipment?
Only if they're moving fast.
Well, if you have a magnetometer too, it should, right?
Yep.
Because those ground magnetometers are very sensitive. So
That
yeah,
was
if you
LC.
yeah, very interesting. So I know in the past few weeks we've been working on doing some data analysis of Tonga, and so we can continue doing that today. I did an update to the GitHub repository today, where I created a script that makes it a lot easier to download the data files. So this is based on a notebook that Christina created first, and then I changed a little bit at the end that lets you download those data files. So how many people on here are up to date or were following along on the data tutorial in the past few weeks? So we've got Todd and John. So okay, we've got a couple of people. So if you go back to the GitHub page now, so GitHub/W2NAF, and I have repositories, and we now have, actually this is on the HamSCI system, wasn't it? HamSCI. Repositories. Yeah. Okay, so if you go to github.com/HamSCI/grape analysis demo, I will put this in the chat here. I have to get my chat. Where did my chat? There's the chat window. Okay. Okay, so if you have the repository on your computer, you should do a pull of that repository and get the latest version. If you need help doing that, let me know. Does anyone need help, or should I keep going?
Got quite a bit of stuff pulled in, so I think I'm even got the whole thing to install on my Mac, so should be
Okay.
good.
All right, good. I got John says good. Todd gave me a thumbs up. So the next thing I'm going to do is, in the past few weeks, we have been using Jupyter Lab, and let me see what I have. So in the past few weeks, we've been using this system called Jupyter Lab, which looks like this. And there's an older version of Jupyter Lab called Jupyter Notebook, which doesn't have quite as many features, and the interface is not quite as fancy. However, what we learned today is that some of the plots that Christina was showing in her notebook, they aren't working in Jupyter Lab quite right, but they do work correctly in Jupyter Notebook. And so if you have Jupyter Lab running, you can go to help, and there's a button here that says launch classic notebook. And if you click that, it will actually take you to the classic notebook interface instead of Jupyter Lab. Once you're in there, I have a new notebook called grape download data.ipynb. And you can click on that.
Okay, I got a silly question. I tried to launch Jupyter from the command line and it says it's looking for a subcommand.
Right, so in your case, you can type Jupyter space notebook and it will automatically load the older notebook interface.
Bingo.
Great.
Wow, it worked. What did
Now,
I do wrong?
Yeah, so at the command line, you can type either Jupyter space lab or you can type Jupyter space notebook, and it will bring up either the newer lab interface or the older notebook interface. All right, now once you did that, were you able to find the grape download data notebook?
Yes, there's a great download data IPYNB.
Perfect. So you can click on that.
Oh, looks just like yours.
Good. You're doing all right, Todd? I see you're nodding.
Yeah, I was muted. No, yeah, I'm rolling along here.
All right, great. Okay, so what you can do there, first thing you can do is you can do a kernel restart and clear all output. And that will go ahead and make sure everything's clear. And then the next thing we'll have you do is we'll have you run this first import cell here. And I almost suspect that some of you might be missing something, so it may yell at you after you run that step. So go ahead and try and run it and see if it yells at you.
So you highlight it and just click on run.
You put your cursor in the middle of it, then you hold down Shift and press Enter.
Hold down Shift and press Enter. Module not found error. Pandas.
So you don't have pandas. So are you using Anaconda or are you using regular Python?
I think I installed. Wait a minute.
Are you running on Linux or Windows?
This is running on a Mac.
Oh, you're running on Mac. Okay.
So I did,
So if you're at your command prompt, do you
I
see
did a
something?
pip install Jupyter Lab.
Ah, okay. So you're not using Anaconda probably.
Correct.
So what you'll probably have to do is you'll probably need to do a pip install pandas.
It's working.
Great. How about you, Todd?
Yeah, I'm using Anaconda, so
Okay. Did it give you any problems with missing modules?
nope.
Great. You are doing well then. If it didn't give any problems with missing modules, you can go ahead and try and keep running the script. Or maybe what I'll do, John, is if you just want to watch, I'll demo the whole script first, and then you can go back and you can look at you can try and figure out your module thing. So the first part of the script is exactly what Christina put together. And the way we have it right now is we've provided a file list with all of the data that's already been uploaded from all of the grapes onto the servers. There are some reasons right now where we can't have the system easily automatically grab the latest file list. We're working on that. It has to do with the file limitations of FTP and some other things. But for now, we're providing a file list, and this first cell reads it, and it will generate a data frame with all the file names. The next cell here, the one that says eliminate.pngs from our file list, it goes through and it parses all of those file names, and it gives you a data frame that has the dates, the node numbers, whether it's running a grape or a regular ham radio station. It gives you the grid square, the frequency, and the file name. And then what Christina has done is she made this nice Gantt chart system where it will take all of that information and you run it, and it waits a minute. And then you get a file that looks like this, and it tells you what node number and how much data has been collected over time and what frequency it's operating. So John, you're node 1, right?
Yep.
Okay. So John has he's been around the longest here, and he has the most data uploaded to our system. But this gives you a catalog of what data is available.
Yeah, we pretty much launched all of the grapes in July of 2020, mid-July, which is consistent with what you're seeing on the plots there.
Yeah.
And there was another wave in January, and then they trickled in after that. Yep.
And if you go down a little bit more, there's another file that's provided in the GitHub repo called nodelist.csv. And this has all of the information about each node. And if you run that cell, you get another table that gives you all sorts of information about each particular node. And after that, this last cell gives you a map. And this map is nice because it's actually interactive. So you can drag it, you can zoom in, you can hover over a particular node, and it will tell you some information about it. And you can use this to help you figure out what nodes you're going to use for your analysis.
What's the difference between the red and the blue?
So blue means that we have data from that person, and red means that they've been assigned a node number for some reason, but have never reported data.
Okay.
So we're
cracking the whip.
That's right. So Christina is working on sending around her people. to the different nodes to try and get data from them.
The data police.
The data police. And I can tell you that Veronica's project requires having a triangular configuration to detect what way these TIDs are moving. And so that's why, like Jim, your station K4BSC, and I'm not sure who KM4YMI is, but these stations might be very useful because Veronica, her station's over here, and you know, we have a lot of stations in case, so this is potentially a nice triangle here. Another nice triangle might be AC0G, might be this way. But we need to play with some of these different geometries to see what's going to give us the best result for what she's doing. Now down here, this is the download data part. So this is the part I worked up this afternoon. So once again, I put DF here for data. DF stands for data frame. This will give you a list of everything you have already. Now what you can do is you can choose what days you want to download data from. So what date range. So I'm going to download everything between April 5th, 2021 and April 10th, 2021. So you could change these dates to whatever you want. And then you can create a list of nodes. So I'm downloading from nodes 7 and 14. In this particular example, I'm going to save the data into the grape_data data directory. And then you just change those things to whatever you want them to be, and then you hit run, and it should automatically go to the server and fetch that data.
Oh, wow.
There it goes.
That is cool. Just feel those raw bits.
They're coming through the pipe. And so this should make it much easier if we are, this should make it much easier for trying to get the data you need to look at a particular event.
That is way cool.
And what's even cooler is if you already have the data downloaded and you run it again, it says you've already downloaded the data.
Impressive.
Yeah, very nice.
Somebody knows how to program.
I think, have you heard of the term script kiddie? that would be me. Yeah, nothing too fancy, but it's getting the job done for the moment.
Yeah, that's nothing wrong with that.
Were you able to download data, Todd?
Yep.
Great.
Yep, works good.
Good. So I guess
is PLOTY a package?
Yes, it is Plotly.
Oop.
So
Helps you spell it right.
yes. And you're probably also going to need the Python-wget,
Yeah.
which is different from wget. Pip install. Well, if you do pip install wget, that might work. I'm not sure.
And we'll see what else it's.
Yeah, just pip install wget should work.
That looks like the last one I have to fight with. So
I think so.
it's doing it. Okay.
Great.
Now. Dun, dun, dun. It ran. Woohoo.
Good.
All the files. That looks good. There's that. Hasn't puked yet. I got the plot box. Okay. There's the nodes. Getting dangerous here. There's the plot of the United States. Getting cocky now. DF. Okay, let's try that. No. Okay, that worked. And last but not least, and it's sucking files down. Look at that. I'm impressed. My software never does that on the first try.
What makes you think it did it on the first try?
Or the second or the third.
I was sitting here with Veronica around 1 p.m. today, and
Oh.
I was writing this thing with her here, and we're like debugging it, like, and then I got it to work on my machine, and then I sent it over to her machine, and it had an error, and I think that error was because we have slightly different versions of Python, so I fixed that, and yeah, now it seems to be working a little bit better.
Okay, I may have mistyped in the data frame below that. Should it be just DF or is it DFT?
DFT stands for data frame temp.
Oh, okay.
And if you look at that one, you can see that DFT has just a list of the files that you actually downloaded or
Okay.
filtered out.
So now I've got that working. So now what?
Well, now that you have that, you just need to know where the files are located, which should be in that. There should now be a grape data directory in your grape analysis demo folder.
Okay, let me go grape analysis download folder. Where did I stick it? Oh no. Thanks. Oh, it might be GitHub. HamSCI. Grape analysis study. Grape data. Tonga data. That looks promising.
Mm-hmm.
Oh yeah, there's lots of stuff there. Okay.
Okay.
Mm-hmm.
So, yeah. So now once you have your files, you can go and you can process them with the same sorts of scripts we've used a couple weeks ago.
Got it.
And you can do whatever you want with them.
Very cool.
So I have a couple questions for you. Now that you see this, John, one question for you. This particular system right now is limited by the fact that we need to provide a file list.txt. And my understanding is the way we get this file list.txt is you have to log into the WWV system.
Uh-huh.
And you have to have a login and a password. And then once you do that, you're able to go download this. And then I'm not sure how Christina, once you get into here, I'm not sure how Christina generates that file list.txt. But
yeah, I'm not sure how she does it either.
But one of the things she said was that you know, she tried automating this, but she hasn't gotten it to go automatically go past that login screen. And I just asked her the question, is it absolutely necessary that this list is behind a password wall?
Yeah, to see that you have to be into what's the program that's generating it, which is on the website. So I would think you have to.
But from my understanding, my understanding of this, my understanding of running these sorts of websites, which I do have some understanding of, they probably don't need to make this a password protected website.
Yeah, she might be just highlighting that out and doing a cut and paste.
Yeah, so I'm not sure what she's doing, but
that would be my guess, because she's eliminating the ping files, which would tell me she's grabbing them. So,
well, the problem with the FTP server is that it only gets you up to 9,999 files when you list it, and then it quits. And of course, we have 14,892 files. So you don't actually know how many files are there.
Right.
And I think the way web servers work, I think they usually don't let you like do a listing.
Actually,
So,
if you do a filter on a particular node, like if you
right,
type in like
but what
in,
yeah, I understand that, but what I'm saying is for people who are going to be using this system to download the data, it'd be really nice if we had a way for them to get the most up-to-date list so they could actually know what data they can go download.
right.
Yeah.
Yeah, it's a Christina problem.
Okay. So
It's above my pay grade.
yeah, I wasn't sure because you seem to be one of the people that was talking to the WWD.
Yeah, they were having all kinds of issues with security and things that were related to the operation of the FTP server and the way it operated. And there were issues with that they were fighting with that.
Yeah.
I don't know. Can't answer that. Sorry.
Okay. So for now, we'll have to periodically update that file list.txt file.
Yeah.
But for the moment,
Gee, that looks familiar.
yeah, that's the way to go. So that's what I have for you in terms of new grape analysis techniques for the day. I now have a way that you can go ahead and download other people's grape data and see where the files are,
Very nice.
where they're located.
That's very nice. That's some good work.
Thank you.
Mhm.
That's not trivial stuff either. So yeah, that's some pretty intense programming there.
Yeah, it really wasn't actually. Well, Christina did a lot of work up here. So like that part, all of that stuff is all Christina's. My contribution was just doing this down here. And it really is just as simple. You take the data frame Christina already created. We throw out the dates we don't want. We only keep the nodes we do want. And then you just grab the file names from that filtered list, and then you just download them one at a time.
Well, the thing that you're not mentioning is you're so familiar with doing this that what you did in probably an hour or two's worth of time would have taken me a week to look all this stuff up and figure it out. So yeah.
Yeah. Well, I guess this just highlights how we all have different skill sets.
Exactly.
Because
I was just going to say that.
I have absolutely zero hope of actually designing and producing any sort of a grape.
But that's just falling off a log for me. So yeah.
Right, see, exactly. I just did this in 20 minutes. I was like, okay, whatever. Rachel has something to show you.
Ooh.
I just came from my earth science class.
Oh, a tornado generator?
Yep.
That is cool.
There
I
it
love
is.
it. That's great. Stand back, Nathaniel. You're about to get sucked in.
Don't worry, I double checked that they were leak proof. I also told the students, remove all your computers from the table. I had them very gently turn over first. And we even had like paint we could do. I'm like, no, that's too far. So I had two of them and the students got a race and see who could do it the fastest.
Now I know why she was drinking so much Coca-Cola at lunch today.
She's been wired for a week.
I'll take it to this.
A plug for IEEE. I said that's where we got the pop-up.
Now take it to the southern hemisphere and see that it goes the other way.
We talked about the Coriolis effect. I had them out there with like rotating the paper, doing a little drawing. I tried to do some more hands-on because the students don't talk. And it's just me sitting going yak, yak, yak for an hour and 15 minutes. And I'm like, I gotta have some activities. Otherwise, we're all going to fall asleep.
Very nice demo. I'm impressed.
Thanks. So I'll let you guys get back to it. I can leave this one here.
Actually, I think we're about ready to sign off.
Oh,
It's
wonderful.
almost 4 o'clock. So
I got a question for Rachel.
Yeah.
Do you need 3 BNC to SMA connector cables for your demo? Because I can bring those to Dayton if you
this
need
is
them.
for the one that breaks the KVL. We need to work on that demo
Yes,
still.
we do. That'll
Yeah.
be a good tip.
Do you need the cables for the BNC connection so you can go BNC to SMA? Because there are SMA connectors on the board.
We might need that.
Okay, I'll bring them to Dayton.
Okay, thank you. Well, thank you very much, everyone. Everyone wish Bill a good road trip to California. He's going on vacation.
Oh my, that's a long one.
Safe
California
travels.
dreaming, California dreaming. Yep.
And Aiden, when do you leave for Colorado?
I will be leaving for the land of Nist Monday. So I'll
Wow.
be also going on a road trip.
Yeah, and that's a permanent one. You're staying out there forever, right?
Well, I mean, I'm coming back here at some point, but yes, that is
In
what they
about
call a
45
permanent
years.
position.
And I'm going to New Brunswick next week.
Ooh,
New Brunswick,
New
in
Brunswick,
Canada.
the Canada one.
Wow.
University of New Brunswick is where we're dropping this equipment off.
That's exciting.
wow, that's cool.
So I'm not worried about getting into Canada. I do worry about them letting us back in.
Bring your passport.
Yes.
And you
Take
might not
pictures
be
of
a
it.
bad idea to bring your vaccination records.
Oh, we got that.
Yeah.
2
They get more
COVID tests
stickety
per
butt.
day.
Yeah, Jim LaBelle and I are going up together.
That sounds great. Well, good luck on your trip and tell Jim I said hi.
Will do.
Oh, and for those
Be
going
safe.
to Dayton, Friday the 20th is also, or I think it's a Saturday, but the 20th is also World Metrology Day. And as your future NIST employee, I feel bound to mention that.
Thank you, Aiden.
I'll bring my
So,
calibrated
who knows,
Fort Wire short.
I may be able to convince them that I need to go.
Thank you. So I guess this will convene again 2 weeks from now, and we will continue working on, we'll get updates and we'll continue working on analysis.
Thank you.
All right.
Thank you
Thank
for the tornado demo. That was great.
You're welcome.
Fractal of the universe.
7-3, everybody.
7-3.
3, bye-bye.
Number 3.
Bye.
Bye.